This is June 2008, question 2. Okay, now it's a linear programming question, and looking at the trend of the exam, linear programming is going to be important. Okay? Now calculate the contribution earned from each queue. Okay, just work out contribution. B, determine the optimal production plan for a typical period, assuming that HC is seeking to maximize the contribution earned. You should use a linear programming graph, the graph paper provided, identify the feasible region, the optimal point, and accurately calculate the maximum contribution that could be earned using whichever equations you need. Now then, the next part will go on, so that's where you need to work out shadow price and consider additional resources. Okay, so we read the question on top. We finish AB. Higgins manufactures and sells pool cue and snooker cue. The cues both use the same type of good quality wood, ash, which can be difficult to source in sufficient quantity. Supply of ash is restricted to 5,400 kilo per period, and ash costs 400 per kilo. The cues are made by skilled craftsmen, highly skilled labor, who are all well known for their workmanship. The skilled craftsmen take years to train, and they are difficult to recruit. That's why the material is difficult to get. Workers also difficult to get. That means chances is they are not enough. Okay? The craftsmen are able to work for 12,000 hours in a period. Craftsmen are paid $18 per hour. HC sells the cue to large market. Demand for cues is strong. In any period, 15,000 of pool cue and 12,000 snooker cue could be sold. The selling price is 41 for pool cue. Snooker cue is 69. Now the manufacturing details for the two products are as follows. Craftsman time per cue, ash per cue, other variable costs, and they do not keep inventory. Alright, now 2 marks for the contribution. Someone cannot say you don't know how to calculate, right? Okay, you calculate on your own, I calculate on my own. Don't wait for me. I'm done, you are done, okay? I'm done, you're done, alright? contribution per Q will be 20. $52. So high. 40. Hey, this one also look at my answer, man. Come on, your contribution more.
老師我記得一隻你幾細？
啊？
我記得一隻你幾細？
我看看你計多少個？你再努力，慢慢嚟。一係快少少，一係快少少就得啦。Okay, now we'll move on to look at B. So now they want you all to use the linear programming graph. So what do you do when you do linear programming? You must have your constraint, right? So first thing you do here is you define constraint. So you all notice your problem or not? Is you are lack of a bit of confidence. You all calculate, I see you all press the calculator, you get the right number, but you still don't want to do your own answer, you still want to wait for me. That means you are still lacking a bit of confidence, okay? So build more trust, build more trust. Where in exam you don't have my answer to copy. You must trust yourself, okay? Okay, so we need the constraint. So let's define the variable. Let P be pool Q, and then let S be snooker Q. Then you put down your constraint. So what constraint do you have? Ash. Ash. So what's in ash? 6, huh? What's ash? Sorry? 0.27 P plus 0.27 S does not exceed 5004. Fair enough? Okay, then the Craftsman. So what's in Craftsman? 0.5 P plus 0.75 S does not exceed 12,000. Okay, what else? Maximum demand, where P does not exceed 15 and then S does not exceed 12. Anything else? Got it. Still got? There's only ash and worker. Correct. And demand. No more there, right? That means the last thing is just to put in a non-negative. The SP must be at least or more than 0. Now, so you put down your constraint. Then in the exam at the side, we need some working for the graph. So to plot the graph, you can just write like that lah. Okay, just write like that to plot the graph. If what? If P equals 0, S is, and if S equals 0, P is. $5,4 divided by 0.27, we have 20,000, right? And then your $12,000 divided back is 16. 12,000 divided by 5 is 24. This one don't need 15 and 12 is just a straight line. So actually the drawing part is really straightforward, right? So we are looking at what? The highest is 20, no? Okay, S the highest is 20, P the highest is 24. So now you need to prepare the graph. Okay. Sorry, I got no graph paper provided. Exam got me. Alright, now we put up the scale. The 20 to 24. The most is I can use 1 cm for 2000. P and S. Okay. So P highest is 24 ma. So 2, 4, 6, 8, 10, 12, 14, 18, 20, 22, 24 thousand of unit. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, in thousands as well. So let's draw in the line. Okay, my first line is ash. 20 to 20. It's easy, right? 20 to 20. 20 to 20. And in the event you get a linear programming question in your exam, please use pen. Don't use pencil. Alright. because I scared you all use the what SPM culture, what graph must use pencil. Use pencil, you're gonna have a tough time. When they scan your answer, the pencil line is very hard to pick up. If the ink is not thick enough, so please use pen. Okay, the first line that I have here is ash. 0.27p, 0.27s does not exceed 5.4. Just label it. Okay, after ash we have Craftsman. S is 16 and 24. 16 and 24. That's easy also. 16, 24. Right, that's the Craftsman. 0.5p plus 75s does not exceed 12,000. So the most, the one that you must draw is these two lines. The rest all very straightforward. Two straight lines. That's why you see question is not very difficult, because they want to see you know how to do or not. Okay. All right. Now the maximum demand for P is 15. 15. P is 15. So it's here. P does not exceed 15. And the maximum demand for S is 12. Right? Now non-negative is nothing for us to draw. This is to show the region will not go below the negative part. So where will the feasible region be? It's all below, so the region must be at the bottom. Okay, so please label it. Huh? 15 I say 看错了 16.5 here. Sorry, see wrongly. P equals to 15. I made mistake, you all also made mistake, I know, right? Cannot be. Your graph you should draw yourself, you cannot be following me, right? Sheet sheet, 谁在 sheet Why sheet? Okay, so that's your region. So I must delete here also. Okay, it's a region. Feasible region. So the optimum point is this, one of it. So usually you put this as O, A, B, C, D, E. So A, B, C, D is possibly one of it is your optimum production. So which one is optimum production? How do you find? Now you will need your objective, correct now? Okay, so I continue with this, then I'll come back to the graph again. Now, to get your optimum solution, objective is to maximize contribution. So objective is, contribution is 20P plus 40S. So we just say based on the contribution and you just inverse the value so that you reverse them. The 20 goes to S, the 40 goes to P. So it becomes 40 for P and 20 for S. Correct? So in this case, to draw the contribution line, we will use P equals to 40, S equals to 20. But when you look at your value here, it's all in thousand, correct now? So you wouldn't be using 40, right? So you got to magnify it. So even I think 400 and 200 is still too small. So might as well we just take 4 and 2000. Okay, so P will be 4000, S will be 2000. Now you just have to write down that to draw you need a value. So what value is that? Okay, just take 4 and 2. Okay, so now go back to your graph. P is 4000, Q is 2000. Okay, so I show the graph. Right, so P is 4000, Q is 2000. So which one is your optimum solution? A, B, C, D, E. Put your ruler here, and then you push all the way to the last point, and that point will be which one? So the last point has to be B, okay? So you follow your line parallel, you push all the way, then we can understand that the last point has to be B. So this is your optimum solution. Okay? So if I just draw a line like that, you don't need to draw it's just to show that this line that we draw, the rest of the point are below it. So that's how we know that this is optimum solution. Okay, so at optimum solution, the question asks what? After you show your point, you must calculate the maximum contribution you can earn. So the question is asking you the maximum contribution. So how do you know what's the maximum contribution? You must first work out how many units you make at point B. Then only you know how much you can get from selling. Yes, you know? So we're going to go back and do some calculation again. Right. Now the production quantity at point B, which is the optimum solution. So point B is a point that is between two lines. One is Kraftmann, one is S. Now the one S we know already lah. So Kraftmann we know is 0.5 P plus 0.75 S is 12,000. And we already know S equals to 12,000. Now that means S don't need to calculate, no? Correct, no? The answer is here. S equals to 12,000. So the only thing we need now is to replace S into the first equation. So P will be 12,000 minus 0.75 times 12 divided by 0.5. So your production is 6,000 P, 12,000 S. Okay, now so the contribution is what? 20 times P plus 40 times S. So 6,000 and 12,000, meaning you will get 600. Is it 600? Okay, so that's your final answer. Okay, that is what they asked us in part B, 12 marks. Now in the exam, if you are not a person that you like to draw graph, then my suggestion is you don't start with drawing graph. You try to leave this answer towards the end. Maybe you don't try to do last also, okay? Because graph can be quite easy to score, because you're not. But if you're not very good, don't draw first, because you draw first, you take very long time. Then you cannot draw properly. After that, your feeling gone already. You get very panicked. Okay, so leave it maybe to your question 3 or question 4, then you do. Okay. Now, so now we see the next part of the question. They say, now some of the craftsmen have offered to work overtime, provided that they are paid double time for the extra hour over the contracted 12,000 hours. HC has estimated that up to 1,200 hours per period could be gained in this way. Okay, see first they say explain the meaning of shadow price, or another word is called dual price. Calculate the shadow price of labor and material. Now, do you have shadow price for labor? Do you have shadow price for labor? Go on. Do you have shadow price for labor? You read question, cannot find one. You must read the graph. Then only you can find go or not. Okay? You got shadow price for labor? Oh, you don't know what I'm asking you. Shadow price is a price that only exists if the resource is binding, not enough, exactly used up. So is your labor binding? Is your labor binding? But you also don't know what I'm saying. Why you look at me like that one? Like I'm talking Thailand like that. The line fall exactly on the labor, right? The labor is binding, correct or not? There is labor having shadow price? Yes. Material got shadow price or not? The ash got shadow price or not? No lah. Ash is on top. Right? Your point is below ash. Right? That means you have more ash than you need. What do you call that? What's the term? Slack. There's a slack. If you have a slack, you won't have shadow price already. Okay? You are not finished using one. Okay? Now, so that's why in this case, when you talk about C, what is shadow price? It's the extra contribution, correct or not? Shadow price is the extra contribution per unit of what? Binding resource. Binding resource is resource that is exactly used up. So based on the optimum solution at point B, labor is binding, but material is slack. So there will be no shadow price for material or ash. Okay, what's the shadow price for the craftsman? The step is you increase your quantity of craftsmen by 1 and see how many extra unit you're going to make. Okay, so my revised production 0.5p plus 0.75s equals to 12,001. Increase it by 1. Okay. Now the other one you can't change. There's the demand that S equals to 12,000. So what is P then? So this is reverse figure, right? So 12,001 minus 0.75 times 12,000 divided 0.5 is 6002. Now, in that case, this actually is very easy because S you cannot increase it, and P you increase by 2. That means the shadow price is the incremental contribution. You can even straight away take 2 unit times the contribution for P. And contribution for P just now is 20. That means the shadow price is $40. Alright? Now if you can do that, then you can see then you can do like that. If not, then you do the way that we always do. You calculate again what's the new contribution, then you minus the existing contribution. Okay? Now, so the new contribution is 20 times this plus 40 times this, so it's 600,000 40. So existing contribution is 600. So the incremental contribution, i.e. shadow price for labor, is $40 per hour. Follow? Okay. D. Now D, they ask us to advise HC whether you want to accept the Craftsman initial offer of working overtime. Discuss the rate of pay requested, the quantity of hours, and any other factor that HC should consider. Okay, I want you all to try this. Usually the more difficult part is here only. The rest are very simple. Okay, whether or not you should accept the offer, discuss the rate and the hour and one factor you should consider. Okay, try this. So what must you do? First, you must know how many hours do you actually need. Because right now we have insufficient labor hour. So the more labor you get, the more you can make, then the more you earn. But then the question is, they say in total they can give you 1,200. But do you need 1,200 or not? That's the first thing you must determine. So this is the line that we see now, right? Craftsman. So the more craftsman hours you get, what will happen? You will push this line out like that, parallel to this line, you push it away. Now the moment you push the line away from here, then you will see the black color dot, the point B will start to move, right? So initially it's here, so it will keep on moving to the right. So that's why just now we say if we increase by 1 hour, you still have the same quantity for S, but then your quantity for P will increase by 2 units. So now how many more units you can get is you're going to push this B all the way to here, fair enough? So this is the point that you're going to see. Okay, so just put an X. Now because once you reach X, you're going to have another problem with your ash. Alright, so even you have more hours, it would be useless, right? Because you look at the ash that you have is restricted. Having the hours you can't use. So that's why the first thing I must solve is how many units I need. How many hours I need to make quantity at X. Okay. First, we shall determine the maximum production quantity. So to determine the maximum labor hours needed, and that is based on the production plan at point X in the graph. So why at point X? Because at point X, ash is binding and it is useless to have additional labor hour because your production is restricted. Okay, so what's my production quantity at X? S equals to 12,000 and then 0.27P 0.27S equals to 5,004. S equals to 12,000, then P will be, so just replace back 5,004 minus 0.27 times 12 divided 0.27, 8,000. Right. So the production quantity at X is 12 for S and 8 for P. Okay. How many hours do you need? So the labor hours required for the above. 0.5 times 8,000 plus 0.75 times 12,000. Fair enough? 0.5 times 8, 0.75 times 12, it's 13,000. Now, you need 13,000. That means the incremental hours that can be utilized is what? It's 13 minus, right now is 12, right? So it's only 1,000 hours. Okay, so they ask you to discuss what's the rate of the pay that they discussed, that they requested, which is based on what? Double the time. Double the double time for the extra hour. That means right now they are paid $18. That means they are now requesting for 36 lah. Okay? Alright. So I just do here. Continue B. No space already. Okay. So the rate requested. Now labor requested double pay for overtime, which means the premium is how much? Premium is the extra. Right now you pay them 18. The premium is another 18. Okay? Means an incremental of 18 per hour. Okay? Now, so the shadow price is how much? 40 per hour, right? So HC will still enjoy an incremental gain of 22 per hour from working overtime, but it's only valid for up to 1,000 hours. So the balance 200, you're not going to use that. Okay. Now, if the 200 also you need to use them, then you're going to pay extra already. So then your contribution will not be so much already, because right now 22 times 1,000 is 22,000. If you're going to pay for the extra 200 at the rate of 36, then your contribution will reduce to 14,008. But it's still worth it lah. Still worth it. Okay. Now, if the labor insists that the entire 1,200 OT hours to be taken up, then the net incremental contribution would only be, so you will take 22 times 1,000 minus 36 times 200 long. So that's where we get 14,008. Now, meaning the rate is feasible. So the rate requested is feasible. Now, one other factor to consider. So what other factor that you must consider that is nothing to do with the amount? So I think we can see issue here is factors on fatigue. Because they talk about craftsmen are skilled men. That means you need their skill in doing the work, and you keep on pushing them to do overtime. It's like you push doctors to do overtime, or you push pilot to do overtime. So if they become very tired, then end of the day the work is affected, so the quality of the outcome is affected. So I just put one last point here, okay? The issue to do with fatigue, that it's having too much job and too tired, so that eventually it will affect the quality. And since you mentioned highly about craftsmen, their skill is very important, so this is an important consideration. Okay, so I just elaborate on that point. So this questions on your linear programming. Okay, so we move on. Okay, turn to December 08. Okay, we look at the shorter question. Okay, turn to December 08, question 3. Alright, question 3, December 08, Henry Company. Okay, now the requirement here in A, so I just verbally discuss A with you, we have no time here, okay? So we just do G. Now describe 5 factors other than the cost of labor and the overhead mentioned above that HC should take into account when you are calculating your bid. So what is this? Read the question, then we know. Okay. B, they say calculate the total cost including all the overhead for HC that it can use as a basis of the bid for the new apartment contract. And C, if the second kitchen alone is expected to take 21.6 hours to fit, demonstrate how the learning rate of 95% has been calculated. Now this question is on learning curve. Okay. Now they say HC provides skilled labor to the building trade. They have recently been asked by a builder to build for a kitchen fitting contract for a new development of 600 identical apartments. Now HC has not worked for this builder before, first time. The cost information for the new contract is as follows. Now the labor for the contract is available. They expect the first kitchen will take 24 hours to fit, but thereafter the time taken will subject to a 95% learning. After 200 kitchens are fitted, the learning rate will stop. The time taken for the 200 kitchen will be the same, will be the time taken for the remaining kitchen. And the labor is at $15 an hour. Overheads are absorbed on labor hour basis, and they have collected information for the last 4 months, the hours they work and the overhead. You see that, then you know is what? High-low, correct not? Every time I see this, I know a bit high-low. Or if not high-low, must be linear regression. Where they give you up to 4 months, you see not? Now HC normally works around 120,000 labor hours a year, and HC uses high-low method to analyze overhead. Fine, given it. Okay. Learning curve is y equals to ax power of b, where the coefficient is negative 0.074. Now all given. Okay. Now so the first part they say you're going to make a quotation for a contract for a customer. Who are you? Your contractor. Your job is do what? You help people to fit kitchen. Okay. So they just pass you all the thing, and then you do the fitting. It's just like the customer is IKEA. IKEA asks you to install kitchen for the customer. Now, but the only difference is now you're talking about a contract that there are 600 apartments, you got to fit 600 same kitchen. So what will be the factor that you must consider if you want to give a quotation? Let me, I'm asking you, if you're a businessman, what will you think of? There's a lot of things, right? For example, like number one, you pay cash or you pay credit. You pay cash and I charge lower. You pay credit, I charge more. Okay? Now, this is a new builder. I never worked with this before. I must factor in the risk as well, right? Because I don't know you're honest or not. What if later after that you run away and all these kind of things? Or probably if it's a new builder, I might want to give a lower price in anticipation that in the future we will get more job. Because it's also a factor, right? Now you ask me to fit the kitchen. Who is going to give me all the tools? The screw, the nuts, all these things. Is it you or me? If you want me to cover, then my cost is higher. Now then again, you must look at issues like, for example, will I have to give you warranty or not? Because after I fit the kitchen, if let's say the kitchen fall off, then do the customer call me and come and repair, or call you and repair? You want me to repair, my cost is higher, agree or not? Okay. Now then after that, if I do the fitting, anything spoiled, is it my loss or your loss? If my loss, then again I must factor in all these things as well, right? So then at the end, who will do all the transportation of the material? So is it you send everything to the house, I just send the people and fit, or must I take lorry and carry and bring all the way there? So who is going to do it? At what time do you expect my worker to work? Because this is going to be fit in the kitchen. So are you allowed that to fit in the morning or fit at the night? Because imagine if fit in the night, then I must get all the workers work OT, the cost is very expensive. So all these are examples, so many factors. So you just imagine yourself as a businessman. I ask you, give me a quotation. What do you think of? Like that only, So that is what you're going to do here in part A. Follow? Now you can re-examine those answers. So most of the points I say also are there. Okay, so this is what you do. You just write down. Follow? Now, what we're going to see here is part B. Now they want us to work out what is the total cost for the entire contract. If it's total cost for the entire contract, that means you must take into account for 600, right? You got to do 600 job. Actually, how many costs you have here? How many costs you have here? What cost? Okay, got labor, 还有 got overhead, 还有 还有没有啦？找不到就是没有了，找不到还要找什么？It's no more of you. What else you want? So there's only 3 things only: labor, variable, fixed overhead. This is actually very simple, right? Now, so we just need you to find how much will the labor cost be, variable overhead, and a share of the fixed overhead. Now, if you want to know how much variable overhead, then you must find the hour. Hour times 15. But problem is the hours is what you got? Learning effect. That's the issue that we see here. The hours got learning effect. So working one. How many kitchens you gonna fit? 600. Learning stop where? 200. That means when you calculate the hours, you must divide into 200 and 400. Okay? So the labor hour for the first 200 set and the labor hour for the next 400 set. Okay? Alright, you try and see. Work out for me the first 200 set and the 400 set. So you must find the average, right? Because the first 200 you still have learning. So the average per set is ax power of b, and a is 24, x is 200, b is negative 0.74. So the average is 24 times 200 power of is 16.21567. Okay, so 16.21567 times 200. You're going to use about 3243.134. Later we round together. Okay. Okay, so these are the first 200 set. Now, but the next 400, the problem is what? The learning stop already. So the learning stop means you got to find me the actual hour for set number 200. And how do you find the actual hour for set number 200? You must take the total hour for 200 minus the total hour for the 199, right now? So this is what we're going to do. Total hour for the first 200 is 3243.134 minus the total hour for the first 199. So 24 times 199 power of 0.074 times 199. It's 3228.116. So it's 15.018, and there's a balance 400. So it's 6007.2. That means the total hours you need so I round it. It's 9250. Okay, now knowing that is 9250, and 1 hour is $15, the cost is 13870. Then you know the variable and the overhead also based on labor hour. Now the only difference is you don't know what's the rate only. So to find the rate, you need the working again. So I'll use my working 4. So I'm going to do high-low method. Okay, working 4. Using high-low method. Now my variable overhead is different in the cost. High is 116,800. Low is 113,600. Divide by 9,006 minus 9,002. Which comes to how much? 8. Yes, it's 8 per hour. Then my fixed overhead per what? Per month. See, you do past year, so after that you know it, So that's why important of practice is this. Okay, so it's per month. Per month is based on any amount. 116,800 minus 8 times 9,006. 116,800 is 40k per month. Now 40k per month, that means your rate will be fixed overhead absorption rate will be 40 times 12 months divided by 120,000. So 4 per hour. So you've got all the figure lah. Now just go back and multiply it. So times 8 times 4. 74,000. 37,000. So total labor and overhead is 249,750. All right. Okay. Okay, now they ask in part C. Now part C, they ask you, the second unit will take 21.6 hours to fit. And if that's the hour you need, can you prove that the rate is 95%? Okay. Usually I give you the rate, I ask you to calculate. Now I give you the hour and I ask you to show me. Why do you know that it's 95%? Now we are talking about the second kitchen. Normally if they talk about the first unit, the second, 4, 8, then you use which approach? You use a table because it's easier for us to see, right enough? Now, so in this case, part C, okay. Basically your cumulative production and your hours per unit, you will get your total hours, then you know your incremental. Now, first you have 1 unit, then you have 2 units. First unit is 24 hours, so the total is 24. They tell you the second unit is 21.6 given. That means the total hour for 2 units is what? 21.6 is the actual. The total 45.6, because it's 24 minus 45.6, then you get the difference. Now how do you get 45.6? It must be 45.6 times this times 2, right? That means you divide that by 2, you get 22.8. And this times the rate will equal to 22.8. So what rate is that? 228 divided by 24. So if you take 228 divide by 24, that's equals to 95%, right? Now you must explain that. Okay, you cannot just show like that, then still acceptable lah, because the examiner just said demonstrate. Okay, so you just demonstrate how you get the rate, so it's fine. If they ask you to explain, then you must put down in words how you get the figure. They must say that the first unit is what, the average is what, then you just write back in words what you show here. Follow? Okay, so that's questions on learning curve. Alright, if we take this into account, then we do 4 questions here. So the 4 questions is equivalent to 1 set for the O paper. Okay, so this is the first tutorial. Now we stop here. Okay, you take dinner break, come back, then we continue.